Hey, so what we did today in class is we went over a new section called the first derivative test. So what we're going to do today is we're really just going to go over what it means to determine key features of the graph using the derivative. That's really our goal for today. So the first thing we talked about is what does it mean for f of x to be increasing? Well, it means a lot of things. We said that it meant that the derivative is greater than 0, the derivative graph is above the x-axis, and that the slope is positive. What happens if something is decreasing on the derivative graph, though? So if the derivative graph is decreasing, that means the slope of the derivative graph is negative. It actually also means that the second derivative graph would be negative. And it also means that f of x is concave down, which is something new. We'll talk about it next time. Lastly, we added one more thing to our notes, which is what happens if f prime of x is negative? That means that f prime of x would be below the x-axis, or we could also say that f of x is decreasing. And lastly, we could say that f of x has a negative slope. So those are all some things we could interpret just by looking at the derivative and the original function. All right, so next thing we talked about, the test for increasing and decreasing functions. So provided a function is continuous and differentiable, if f prime of x is greater than 0, then we can say that the slope of f is positive, or we could say that f is increasing. Similarly, if f prime of x is less than 0, then we can say that f is decreasing, or you could say that it has negative slope. If f prime of x is equal to 0, we could say that it's neither increasing nor decreasing, which is what's called a critical value. Really quick, a critical value's definition is basically it's where either the derivative is equal to 0 or it's where the derivative does not exist. So those are the two criteria for a critical value. So the first thing we started off with was intervals on which f is increasing and decreasing. It says find the open intervals on which this function is increasing and decreasing. Well, the first thing we did was we used our graphing calculators. We used the min and max features on our graphing calculators to determine the intervals. After that, we tried to figure it out without using our calculators. So in order to do that, we needed to figure out where were the turning points. Where was my function changing from positive slope to negative slope and negative slope to positive slope? And that specifically happens at maxes and mins, and that's where the derivative is equal to 0. So if you want to find out where a function is increasing or decreasing, you need to find out where the derivative equals 0. So we did that. We found that the derivative was equal to 0 at 1 and at 0. From there, we created what's called a first derivative graph. A first derivative graph or test is a number line where I put the critical values, which are where the derivative is equal to 0 or undefined, onto the number line. So 0 and 1 go onto the number line. From there, I'm going to pick a number that's less than 0, like, I don't know, negative 1, and I'm going to plug it into the derivative and see what I get. If I plug negative 1 into the derivative, I get 3 times negative 1 times negative 1 minus 1, and I don't really care what the output is, I just care is it positive or is it negative. And it's positive, which means everything from negative infinity all the way up until 0 has to be positive. It has to have a positive slope or be increasing. We use the same method to figure out between 0 and 1, we used 0.5, and then to find out between 1 and infinity, we used 2. So we can see that the graph is increasing from negative infinity to 0, and then it's also going to be increasing from 1 to infinity. It's decreasing where it's blue, which is from 0 to 1, and that is the first derivative test. That's how it works. So basically, a strategy for using the first derivative test is to, number 1, find the derivative, set it equal to 0, put those critical values onto the number line, and remember, it's sometimes critical values can be where the derivative is undefined, so keep that in mind. And then use testing points to determine if the value would be negative or positive. From there, you can find if it's increasing or decreasing. Okay, so we practiced a little bit more. Some other things that we kind of made note of is that when a function changes from negative to positive, we know that that point has to be a relative minimum. It's also a critical point. If f prime of x changes from positive to negative, that means the slope goes from increasing to decreasing, which means that must be a maximum. If f prime of x is positive on both sides or negative on both sides, then we can say it's neither a relative min nor a relative max. All right, so we did one more practice problem applying the first derivative. I wouldn't get too much into this one. The main point of this is that we took the derivative and set it equal to 0. 1/2 is equal to sine of x at pi over 6 and 5 pi over 6, which is a nice review of trig. And then from there, we put our critical values onto the number line, remembering that this is the first derivative test, so we need to plug into the first derivative, not the original. And this was the result. After that, we just started the next question, so we'll go over the next question starting tomorrow. So if you have any questions or need more clarification, feel free to send me an email, and I'd love to get back to you.